We can only examine the impact of different scenarios on the basis of a reliable model. We need realistic scenarios in order to make decisions. But how do we create realistic scenarios? Dr. Marco Giorgetta, Research Assistant at the Max Planck Institute for Meteorology in Hamburg, will show you how the data is selected.
What is a scenario? In general terms, a scenario describes a sequence of possible events. Novels, films, or simulation games, for example, follow specific scenarios, which are usually consistent and plausible. But what is a climate scenario? It too describes a sequence of possible events. Events that significantly influence the evolution of the climate in the future. And it should also be consistent and plausible. Climate change scenarios are based on the major factors that influence the future climate. These include demographic trends, economic growth, which of course also includes global and individual wealth, technology and how it is used, particularly in producing energy, and also policy, for example, climate policy. Once these major factors have been selected for a scenario, they can be used to derive the progression of greenhouse gas emissions and also the changes in land use. Subsequently, we can use this to estimate the concentration of greenhouse gases in the future. Thus, you produce a climate scenario which provides all data required by a climate model to conduct a climate simulation. The climate model can then describe the climate change for a given scenario. As you can imagine, there are many routes to the future, all of which are possible and plausible and represent a consistent description of the future world. This brings us to the concept of scenario uncertainty. A look at the literature will reveal that there is actually a large number of scenario descriptions. This emphasizes how great this uncertainty is. If we now select one or more scenarios for climate simulations, we can examine the effect of scenario uncertainty on the climate model results, such as the temperature trend. Recently, climate research often used the representative concentration pathway scenarios. There are 4 such scenarios. Despite being so few, it is claimed that these scenarios can cover the broad range of possibilities already described in the literature. This graphic illustrates what we call the radiative forcing of the scenarios. For the sake of clarity, we have selected 3 of the 4 scenarios. Radiative forcing describes the overall effect of external factors, such as greenhouse gases and aerosols on the radiation balance, and is relative to a base here, in this case 1850. The topmost curve describes the RCP 8.5 scenario. The radiative forcing first slowly increases up to the present day and then steadily increases more sharply until the year 2100, where it reaches a value of 8.5 watts per square meter. And that's why this RCP scenario is known as RCP 8.5. We also see the RCP 4.5 scenario here, where the radiative forcing increases too, but less sharply. The radiative forcing will stabilize in the second half of this century, becoming approximately constant until 2100 and reaching a value of 4.5 watts per square meter. The last scenario here is RCP 2.6, which is somewhat distinctive because the radiative forcing reaches a maximum in 2040 and then decreases to 2.6 watts per square meter in 2100. These substantial differences in the scenarios are due to different assumptions. A climate policy is highly significant. The topmost scenario has none, while one has been adopted in both the middle and the bottom scenarios. In the latter case, a very ambitious policy has been adopted, which does everything to reduce CO2 emissions and to limit the global mean temperature increase to less than 2 degrees by 2100. We rely on climate models to check whether we will manage to limit the temperature increase to less than 2 degrees. This graphic shows a climate simulation using the Max Planck Earth System model, which ranges from the past into the future. It specifically shows the global average temperature. We see how the temperature increases from 1850 to the present day and then proceeds along 3 different routes according to the underlying RCP scenario. We can then compare the achieved temperature increase by 2100, about 5 degrees for RCP 8.5 over 2.5 degrees for RCP 4.5 and about 1.7 degrees for RCP 2.6. Therefore, this model with the RCP 2.6 scenario achieves the objective of the scenario, which is that warming stays below 2 degrees. Whether this will also be the case in the future, of course, depends on the actual policy pursued in the coming years and decades.